Prabhas, can you listen to me? Hello, Shashank.
Yes, I can hear you.
Prabhas was not able to listen. Hi, Vilawan. You can also unmute yourself. And both of you, please start your video.
Okay.
Yeah. And Shashank, you can share the PowerPoint and you have 10 minutes to present.
Professor.
Yes, I'll start my video. Just 1 minute.
Yeah.
Professor.
Vilawan, please start your video.
Yes, Professor, can I share my screen?
Yeah. Okay. This is the screen of Vilawan, I think.
Can you see my slide?
Okay, so now this is 105. So till 125 you can present. So you can start now.
Okay. Good afternoon, Professor, and everyone also. Today we will talk about fuzzy logic in geographic information systems. Okay. We will start to compare fuzzy logic and grip. There are two images. One is clear, but other is blur. For the grip set are clear and visible boundary, but for the fuzzy are not clear. In the grip set, when we can see the boundary and we can see the red dot, it not touch the polygon. But for the fuzzy, if I ask 10 students, 6 students may say yes, it touching, while 4 students may say that not touching the polygon. So the degree of trueness for red dot touching the polygon is 60% and degree of trueness for red dot not touching the polygon is 40%. Let's see an example how the fuzzy logic is calculated. Okay, first let's define two roots and show in the yellow highlight. If 100% sunny and 100% warm, then we can drive 100% fast. And if 100% cloudy and 100% cool, we can drive 100% slow. But if the weather is somewhere in between 0% and 100%, and then what should be the speed of car? There with the help of membership function, we can get an answer. Let's create question. If the temperature is 65 degrees Fahrenheit and cloud cover is 25%, how fast should I drive? These two graphs are membership function and given by expert. This expert can be with a person. 0 is false and 1 is true. The value at 1 are said to have a 100% degree of trueness, according to experts. At 30 Fahrenheit, the temperature is truly freezing, but when it gone beyond 30 Fahrenheit, then it is a combination of freezing and cool. The degree of trueness decrease for freezing and increase for cool. Okay. Similarly, 100% degree of trueness for warm is 70 Fahrenheit, and for hot is 90 Fahrenheit. Similarly, for the second graph, for the sunny periodicity of tunnel is 7%, 20%, and cloudy maybe 50%, and overcast 80%. From the question, if it's given 65 Fahrenheit, so we can find 65 Fahrenheit on the x-axis. When we locate it, we draw line up. This vertical line touch cool and warm. For cool, it touches at approximately 0.3, and for warm, it approximately at 0.7. And for 25% cloud cover, the vertical line touching the sunny and cloudy. For the cloudy, is at 0.1, and for sunny is at 0.7. Next step. Okay. Look at the yellow box first. Let's put this membership value in the rule. We use an operator. We get 0.7 and 0.7, which give a value of 0.7. And for second equation, we get 0.1 and 0.3, which we give a value as 0.1, because an operator, we will get a minimum value from this one. Okay. If we look at the graph, this slow and fast membership function can be given by expert like a traffic police. According to the expert, speed of 25 miles per hour are too slow, and 75 miles per hour are too fast. And we can multiply the result of the and operator to this value correspondingly and add them and multiply them by a total of an operator result, so we can get the answer. So according to fuzzy logic, if the weather is 65 Fahrenheit and 25 cloudy, we should drive at 68.75 miles per hour. Okay. Shasha, can you share?
I will share my screen now. Okay, so from my side, I will explain how fuzzy logic can be used in GIS. So for this term paper, I chose one paper, the groundwater suitability analysis for drinking. So what this title means is that if we get water from under the ground, is this water safe for drinking or not? So we want to create a map to map these zones, a suitable zone, a moderate zone, and an unsuitable zone. So this is the study. This is the study area in the paper. It is in the India country, Tripura province, and a district called Agartala. So in this Agartala, okay, I'll go to the next slide. Okay, so this is the methodology of the paper. So in the Agartala district, 35 35 samples were collected from different locations. I will explain this same methodology in the next slides, but right now I just want you to focus on the right side, the WQI map. The WQI means the water quality index. These values are for the water, and these are standard values and are accepted by everyone throughout all the countries. So what we did was we took these WQI values and created one and applied these values on the study area district and created one suitability map through the WQI values. So this is that WQI map, and we will use this map at the end to compare with our output maps. So yeah, and so when so groundwater has some physiochemical parameters, or in GIS language, I want to say that groundwater has some attributes. So these attributes are sulfate, nitrate, chloride, iron, bicarbonate, magnesium, calcium, pH, and electrical conductivity. Okay. So after reading the paper, I created this GIS model. So the blue color denotes the inputs, yellows are the tools, and green colors are the outputs. So we use our district map, which has water quality attributes as our input. So we use the ordinary Kringing interpolation technique and do interpolation for each and every one of the attributes, starting from electrical conductivity to pH. So we will so after doing the interpolation for each of these attributes, we will get interpolation maps for each of these attributes. So the green colors, the green colors are the raster maps, and these raster maps are the interpolated maps. If you want to, I will show you those maps. These are those interpolated maps of the water attributes. So if I just explain one map, the first map, EC map, it if we look at the legend, the black color denotes a very high value, and from the map it shows that one sample location has a very high electrical conductivity, and this location is not suitable for drinking. Now, since we've got 9 interpolated maps, we will use these maps as inputs for the fuzzy membership function. Fuzzy membership function is another tool which we can find in the ArcMap toolbox. So after applying fuzzy membership functions to the interpolation maps, we get fuzzified maps. So these are those fuzzified maps, electrical conductivity physics. And if you look at the legends of each of these maps, the values are ranging from are in the range from 0 to 1, and like fuzzy logic has and by definition fuzzy logic values range from 0 to 1. If we again look at the first map, EC, the value 0 and the value 1. So one sample location has a white value. It means that this location is not suitable for drinking the water. And this map is very similar to this map, only the colors are inversed, but the meaning is the same. Okay, so back to the GIS model. Now we apply the fuzzy membership value, and so in the next step we will get fuzzified maps of each of the attributes. Now we want to overlay these maps, or we want to stack them. But when we do this overlaying operation, we have to, there are again various methods. We can use the AND operator, or operator sum, product, or gamma. And will take the minimum values of all the attributes, or will take the maximum value of all the attributes. Sum will add all the attributes, product will multiply them. Gamma is the product plus sum raised to the power of gamma. So I will show you the fuzzified operator maps. Okay, please ignore the green box and the water quality index map. Right now, just I want you to focus on the fuzzified output maps. So these are the fuzzified output maps which got created. The first one is the AND or sum, and it ends at gamma 0.1. So if you look at the or operator and the sum operator, like I said, sum adds all of the sum adds all of the values, and or takes the maximum values. That's why these or and sum maps are dominated by one color only. Okay, so since we got the fuzzified operator maps, we want to compare it with the water quality index map. So there is one tool in ArcMap called band collection tool, and this band collection tool finds the correlation of it finds the correlation. So okay, so we compare the AND operator and the WQI map. We compare the OR operator and the WQI map, and we do this up to the gamma operator and compare it with the WQI map. And it was found that gamma, okay, back, it was found that gamma 0.9 has the most correlation with the WQI map. Hence, gamma 0.9 will be will be chosen as the suitability map. So the conclusion is that fuzzy logic can be used to find the drinking water suitability. Sir, that's it from my side.
Thank you, Shashank. So, Prabhas, do you have any question?
Yes, I have questions like, okay, you apply the logic operator like AND or sum, right? So what if I use the just simple map overlay? You think that the output map is going to be the same or not? Like within the lab, right, to find like a suitable area for rice farming. In that one, we use the AHP, just normal simple AHP. But on the same thing, if you do like that with your data set, but change from the AND or sum into like a map overlay, like A plus B multiplied by the constant like that, you think the output is going to be the same?
A plus.
Yeah, because now you have 9 maps, right? 9 interpolated maps. Yeah, and then you overlay them together by applying the fuzzy logic, only AND, OR, and sum, right? So if you use just simple map overlay, you think the output is going to be the same?
I think like one of the output will be the same. If we use just the fuzzified, if we use these fuzzified output maps and do the overlaying operation, one of the outputs will be same.
Because I see that if you apply only AND for everything, A and B and C and D, and you also do the A or B or C or D, right, in the calculation. In the operation. Yeah, you have AND or sum, right?
These are separate operations. Separate.
So in the suitability area, you apply all the things to find the one map, or you just put like map 1 and map 2 and map 3 and map 4, and the next output is map 1 or map 2 or map 3, or you mix everything together?
Oh no, it's not mixed. Everything is done separate actually.
Pardon?
For each of the operator,
Mm-hmm.
like for the AND operator,
Yeah.
like when I select the fuzzy overlay operation, then the drop down menu will come and it will ask me to select the attribute columns. So for AND operator, I will select 9 attributes. For OR operator, I will select 9 attributes for some 9 like this, and I will get separate maps. Like these operator outputs are not linked to each other. That's what I want to say.
Okay. Villawan,
Yes, sir.
what is gamma function?
Oh, pardon.
Gamma.
Okay, I have problem with internet connection. Okay, now I'm back.
Okay. Okay, Prabhas, I will ask one question from Kun Villawan. After that, you can continue. So, Kun Villawan, what is gamma function? Slide
So-
number 13, gamma 0.9 has most correlation. What is gamma?
Sorry, teacher. You mean
Gamma.
membership?
Gamma function. Slide 13, gamma function. Okay, Kun Prabhas, you can continue with Shashank.
Okay, it's like you have 9 interpolated maps, right?
Yes.
Yeah, and you need to find the suitability area. No, I mean like a WQI map.
Mhm.
So you need to overlay them together by applying the fuzzy logic.
Yes.
And you apply and or sum, right? It's like you
Yes.
overlay using those operations. And if you apply and you get the minimum value, and if you use or you get the maximum value. So I just wonder,
Yes.
for example, if you have only 2 maps and one map has the maximum, one map is the minimum. So I don't know. It's like if you apply only these two in some area, in particular area, maybe it's suitable for something, but not
Yes. Yes.
suitable for something. So when you apply them together, I wonder if the output is going to be the same if you
Oh.
apply the AHP.
Oh. Okay.
You got my point, right?
Yes. Yes. So you want to say that if we overlay the minimum map and the maximum map, will the output be the same?
Yeah, like you just normal overlay them. 9 maps.
I don't think output will be the same because I think the operation will be done by adding minimum, maximum, and averaging.
Mhm.
But in gamma operation, it's not just averaging. It is gamma is equal to product plus sum power to the gamma, and this
Mhm.
power to the gamma can be 0.1 or 0.9. So
Mhm.
the output will be different.
Mhm. So the criteria for selecting the most suitable map is the gamma function, is a gamma value.
Yes, we used band collection tool,
Mhm.
and this tool finds correlation, and then gamma 0.9 had the most correlation with the WQI map.
Mhm. And all the maps here you get from the paper, right?
Sorry?
Or the output map you get from the paper. You didn't make it by your own, right?
No. This all maps are from the paper.
Okay, good. So I have one comment that if you want to make the map like this, the suitable area has to be the green, not suitable has to be red. Just comment, just so you know.
Yeah. We discussed this last time. You told me if possible change it, but this is from the map. This is from the paper only. Screenshot of paper.
So in your opinion, you think which approach is suitable to do this, like the fuzzy logic or the AHP?
Uh, I don't know, but after reading this paper, I do feel like fuzzy logic is a good approach, because uh, we have a yes and we have a no, and there are a lot of answers between yes and a no, and fuzzy logic gives these answers. So I will go with fuzzy logic.
Okay.
Okay. So I asked a question to Kun Bilawan, what is gamma function? She is telling it is a membership function in the chat box. What is, please explain this membership function.
Uh, okay. A membership function represent the degree of trueness in fuzzy logic, right? Yes.
So what is, how to decide? There are nine input are there, and then how to get the fuzzified from the gamma 0.9. Need to try gamma with some other thing like 0.8, 0.7, whatever. What does it mean? What is gamma? Why not alpha? Why it is gamma? What is gamma?
I think is for short the degree of trueness.
Degree of?
Degree of trueness.
I could not understand. Can you type it on the chat box? Yeah, you can type it in the chat box. I will read it. Okay. Okay. Thank you, Shashank and Vilawan. Now we move to the next group. Next person is Coco. Miss Coco, can you share your screen?
Yes, sir. Can you see my screen, sir?
Yes, yes, I can see.
Okay, so good afternoon, everyone. I'm Professor Nitin and Mr. Purpose. Here, I would like to present about some kind of what I have did for my special study presentation. I did statistical analysis of the COVID-19 outcome in the ASEAN country. My title of my special study is the impact of behavior, healthcare, and the socio-economic factor on the COVID-19 in ASEAN country. Okay, today I will introduce about what I did. That is the outline of the presentation. I will introduce about the epidemiological spatial analysis, my system design, data collection, and the pre-processing step, spatial weight matrix, K nearest neighboring weighting method, and the Lisa map, and fitness test model to be applied, and the regression method, and result comparison, and the conclusion. That is the outline of this presentation. And if you're wondering about what is the spatial analysis and the traditional analysis, spatial analysis is like it is working on the raster format, while traditional analysis is working on the point line and the polygon. In spatial analysis, it considers about the location of their attribute that we are taking into we are analyzing, but in traditional GIS we don't consider about the location. And in the traditional statistic, we can compute like the common value from our attribute, but instead of spatial analysis, we can do like the method of variation, like the gradient changes and the over the continuous geographic space. This picture was taken from the online. And spatial statistical analysis of the ASEAN country by focusing on COVID-19 confirmed cases, total death, And socioeconomic factor, behavior factor. Behavior factor means male smoker and the female smoker, and the healthcare factor is performed. This analysis was done by using the RStudio software. And I would like to explain about the study area, but I think since we are living in Thailand, so you guys may aware about what the ASEAN is. ASEAN is the association of the Southeast Asian nation, and it is like the regional grouping that allow us to travel among ASEAN countries without the need of visa for 2 weeks, I guess. But that was broken because of the COVID situation. Okay, its purpose is to promote the economic, political, and the security cooperation among its member countries. Members are Brunei, Cambodia, Indonesia, Laos, Malaysia, Myanmar, Philippines, Singapore, Thailand, and the Vietnam. So my study is focused on the COVID-19 data of the ASEAN member country. In figure 2, I have stated about the COVID-19 incident rate of ASEAN countries on January. But according to the statistic analysis, we found out that the influence of COVID-19 on ASEAN country is less than the influence of COVID-19 on the European country. And this is the objective of my study, to conduct the spatial regression, conventional regression method on the COVID-19 data. And then to find out the correlation of my previously stated data and the COVID-19 incidence, and to analyze the result of various spatial and the non-spatial regression model, because it only gives you the number. So we need to analyze what those numbers mean, and to propose the best fit model based on my fitness test method, and to determine the factor that has the most impact on the COVID-19 situation of the ASEAN country by analyzing the spatial regression result. Okay, sorry. This is the literature review that I did. I did a lot of literature review about what is the spatial analysis and that I did on the COVID-19 data. And according to the paper one, I found out that it was done the HY analysis based on the symptom. Because as I checked, Johns Hopkins University stated that if patient is older, chances are it can survive the several cases, so several symptoms, so it may lead to the high mortality rate for the people over the 16 years old. So according to the outcome, the mortality rate of the COVID-19 infected people with underlying disease diabetes is 3 times higher than the mortality rate of COVID-19 infected people with no diabetes. So it means that if you have the underlying disease diabetes, and then chances are you may suffer the severe symptom. And if the person is older than 60 years old, chances are you may lose the patient life may risk. And another one is just the discrete analysis of the global impact of COVID-19 using the data started from the December 2019 to the March 2020 at the country level. It considered for the every country. So prevalence of cases, fatality attributed to the COVID-19, the case fatality rate and the COVID-19 incident rate based on the population data, and it just is like plotting on the map and showing the line graph, pine chart, such kind of things. And then country study stated that country with the high COVID-19 prevalent data does not seem to be resulted in the high COVID-19 incident rate. This is the system design of my proposed study. It is very simple that I just did the standard deviation normalization on my input data, and then I performed the spatial hotspot analysis, because when we are doing for the spatial correlation analysis, we need to check our data are spatially correlated or not. Otherwise, spatial regression method will not be useful. So according to my spatial hotspot analysis, I found out that there's some kind of spatial relationship exists. So I proceed for the regression model analysis by using the OLS, ordinary least square method, spatial lag, and spatial error model. And then I computed the R-square and the Akigai information criterion AIC for the best fit model. And then based on those scores, I select the best fit model and the proposed. So here is the independent variable. Independent variable means input to my regression model. In healthcare data, I use the diabetes prevalence rate and the cardiovascular death rate. I selected these two because the diabetes prevalence rate study already stated that it can increase the mortality rate, and the cardiovascular death rate is also considered because if patient has the some kind of intense underlying diseases, how it is related to the COVID-19 incident and the mortality rate. And then socioeconomic factor are included population density, population in urban, population in total human development index, GDP per capita, life expectancy index, and the international inbound tourism index. So I included the three population indexes: population density, population in urban, and the population in total. My assumption is that if the population density is higher, the chances are it can be the more higher incident rate. And then if the population urban is higher, chances are if in urban, people go to the public area so much, right? So if people are living in the urban too much, and then they may use the public transportation and the public area, and then chances are the transmission rate may be higher. And the population today is the, I would like to say, because if you have the 1,000 people, and then chances are you can get the 100 incident rate. But if you have the 10,000 people, and then chances are you may get the 10,000 incident rate, but we cannot tell like 100 by 1,000 is higher. So I also concluded the population into the index also, and the human development index, GDP per capita, and the life expectancy. Because I think like that, if those index are higher, chances are incident rate may be lower because of the higher standard of lifestyle and the higher standard of healthcare facility. I think like that. And then international inbound tourism index is because if the tourists came into that country so much, the chances are transmission rate may be high. And behavior factor, I use the percentage of the female smoker and the male smoker because COVID-19 is the respiratory diseases, so it can attack to the patient. Can it be attacked to the patient if it has the smoking behavior? That is the reason I choose the behavior factor. So dependent variable is the output of the regression model are the COVID-19 mainly outcome, and the total confirmed cases and the total death cases. I use that factor. And then output is there. My expected output of my special study is the examination report on the regression report, and the compare performance of OLS, spatial lag, and the spatial error model. I think you may clear about my system design and then my proposed outcome. Okay, here is the data collection step. Data collection step is I collected daily COVID-19 data, cumulative cases, total confirmed cases, COVID-19 death cases, total COVID-19 death cases, cardiovascular death rate, diabetes prevalence rate, female smoker, and the male smoker from our ward in data organization. You may ask like, why not WHO? I also checked with the WHO, but I collected the data from our ward in data because it has included the other factor like the cardiovascular death rate, diabetes prevalence rate, female smoker, and the male smoker ratio. And then I also check the data are correct or not with the reference from the WHO. Human Development Index, International Inbound Tourism Index, Life Expectancy Index, and the GDP per capita index are collected from the United Nations Data Bank. So here is the attribute table of my input shapefile. And then as you can see, the data are ranges in the different ranges. So the next step is how we pre-process the data before performing the analysis. So data pre-processing, collected daily 19 COVID data are same as the monthly data and then matched with other indexes in the several years we find and then matched with the shapefile. Trust me, creating a shapefile for my proposed study is a really, really hard for me because I have no clue about how to create, and luckily I was passed. Okay, and then I did the standard deviation normalization on my attribute data. Normalization, why we did normalization, you may ask. Normalization is that if we need to normalize our input data to put the data into the similar range, because if the data have the higher range, if you have one data that is ranging from the 1 to 100, and then another data that is ranging from the 1 to 10,000, so chances are system may put more bias to the data with the wider range. So in order to reduce the bias, we did normalization on our data. So standard deviation normalization is feature minus mean of that feature divided by the standard deviation of the feature. So this is the attribute table of our my COVID-19 January 2021 saturation after the data normalization. And once I have finished the data normalization, I computed the spatial weight matrix, because we are doing spatial analysis, right? So we cannot put weight wherever I went. So we need to compute the weight by using the traditional or the adjacency or the distance-based method. So spatial filter methods are used to determine the spatial relationship between entities, and the relationship is determined by the geometry. There is two types, adjacency and the distance. So adjacency is stated in the figure 6. It is used on the, matrix base value, and then it has first order. First order means the neighbor that is connected to the one we are searching for, and it has rock. Rock means that consider the neighbor with shared borders only, and then queens mean both shared border and the vertices. And then second order is like this. But in my proposed study area, I have included the Iceland region, which do not work with the adjacency method, because Iceland region, they did not connect with any other in the boundary. So I use the distance-based spatial weight method is applied. So what is distance-based spatial weight method is calculated? I explain in the figure 8. Let us say K1. Let us say the polygons are as the country that we went to find the neighbor, and then it is like we compute the centroid of each polygon and then draw a line directly to that polygon from the one we went to find the neighbor, and then we compute the Euclidean distance, and then whatever distance measurement you can compute, and then we compute the distance measurement and then this line, and then we selected the lowest distance one. How many selected? It is based on the user-defined parameter. Okay. I use the k nearest neighbor weighting method. So it is used to find the neighborhood by using the distance method. So there are 3 types of distance method. Not more than not 3 types. I think there are a lot of the distance equation, and the most popular ones are the Euclidean, Manhattan, and the Minkowski. Those are different based on the things you want to use. Okay, Euclidean method is applying in this study because it is simple, and then also it is efficient for my study. So here is the distance matrix of the k nearest neighbor method, and then I define the parameter of the neighbor as 4. So it computed the distance method for the each Iceland, and then return with the 4 country which has the lowest Euclidean distance value. Here can the locale indicator of the spatial relationship Lisa, Moore, and I map. So previously I did with the adjacency method, metric things, and then I'm trying to compute the Lisa map, and then nothing final. I was so upset, and then I changed to the distance-based method, and then I computed the Lisa Moore map, and luckily they shows the some spatial dependency. Lisa Moore method is like it is compute the Moore values of the each attribute, and then it plotted in this the Moore scatter plot. Here you see low high and low and the high low, and then it calculate the regression line based on the Moore statistic, and then plotted the each number, and then once the feature that plotted near to the plotted near to the regression line. Strictly, we can say as p-value less than 0.05, where b considered as significant, and then it will show in the map. So here you see Philippines is located near the regression line, and then it is definitely lower than the p-value 0.05. So it is stated as the high in our local Moran map. High means high value are surrounded by the high value neighborhood, and high low mean high values are surrounded by the low value neighborhood. And then so we can say as high as hotspot and then low as the cold spot. So we can use local Moran statistic to identify the local cluster and the local spatial outlier. Local spatial outlier means it is different between its local value. Okay, here how it is the local Moran map is created. Okay, here can the ordinary least square method. It is not the spatial regression method. It is the ordinary traditional regression method. So OLS method performed well with the continuous quantitative data like weight, speed, or the age. It is based on the straight line formula y is equal to mx plus b, where y is the dependent variable and then it is the continuous explanatory variable. That means independent variable. You know that I explain it is. The H will be the behavior factor, socio-economic factor, and the healthcare factor, and the Y will be the outcome of the COVID-19 situation. B is the intercept of Y at H is equal to 0. Here I show. And then M is the slope of the coefficient. And here, this is the formula. Here is the illustration of the ordinary least square formula. Here you see we do not consider the influence or other variable, other factor on the one we are finding. So here in spatial lag model and the spatial error model, let me check my note first. Okay, spatial error model is a use of what is it check for the spatial dependency and the error chain, and while spatial lag model is the check for the spatial dependency and the dependent variable. Okay, let us see if we are talking in text. I think we won't understand. So when it comes to the figure 12, we see that we check the spatial influence between the dependent variable, and then here we check in figure that we check the spatial influence between the error terms. So this is the explanation about the two model. Okay, so fitness test model to be applied. Once the regression method came out and the result, we need to find out if it is fit enough or it is good or not. So R-square and the Akika information criterion, AIC value are used to determine the fitness of ordinary least square, spatial lag, and the spatial error model. R-square is the proportion of variation in the outcome that can be explained by the predictor variable. And then R-square value higher than 0.65 is determined to be good, while low AIC value are the better. So AIC determine the relative information value of model using the maximum likelihood estimate and the number of parameter independent variable in the model. So let us see. Oh, here can the result comparison. Okay, the first model is the total confirmed COVID-19 cases and the population factor. I explained the population density, population today, and the population event. And what I'm expecting is if the population density is higher, the COVID-19 confirmed cases will be higher. Population today is higher, COVID-19 confirmed cases may be higher, and the population event is higher, COVID-19 cases will be higher. So I'm expecting to have the positive coefficient in mind the regression model output. So let us see. So in the coefficient value, as you can see, there are negative value and then there are positive value. So if coefficients are the stating. Okay, where is my coefficient things? Okay, coefficients are the stating how much related between the dependent and the independent variable, and then it or negative and the positive sign define the relationship among the two. If the coefficient is negative, it means the negative relationship. If the independent variable are higher, the dependent variable may be lower. Positive coefficient stated that the positive relationship. If the independent variable are higher, the dependent variable value will be higher, like that. So as I stated before, I expected to have the positive correlation in all three variable, and then as we notice, population density is came out with the negative coefficient in every three model, every negative coefficient in all three models, which did not support our hypothesis, but in population today and the population urban is came out with the positive correlation. That means if population is higher, the total confirmed COVID-19 cases will be higher. And then in population today model have the significant p-value. And when I have computed the R square and the AIC value, and let us check according to the analysis. Oh, what is it? Okay, wait a minute. I think I have a little bit problem with my computer.
Coco, can you finish it in 1 minute? Go to the
Okay,
conclusion,
sir.
because
Yeah, sorry, sir. It's taking too
yeah,
long.
no problem, because time is less.
Yeah, sir. I'm very sorry that I thought too much. I think like that. So
No.
I want sorry, sir. I want to explain what I was learned. Yeah. So this is the conclusion and the discussion. By analyzing my Lisa Moran I analyzed that the Philippines is stated with the low value or low and high in the GDP and the life expectancy index and the international inbound tourism and the human development index and diabetes prevalence rate, male smoker ratio, and white height in the female smoker ratio and the cardiovascular rate. Okay, the low height mean the independent value, the expected value low is surrounded with the high value, and the high height mean like that. Okay, the highest influence for the total COVID-19 confirmed cases model is the total population factor. Coefficient is a 0.90281 and the p-value is 0.0063. And the major influence on the death cases is the diabetes prevalence rate, but sadly its coefficient is negative. It came out with negative relationship while we are expecting to have the positive relationship. So I think we need more analysis. And by male smoker ratio is there, coefficient is 0.90158. If the male smoker, if male smoker percentage is high, COVID-19 mortality rate will be high. And then the study is useful to analyze the COVID-19 situation of the surrounding country in the ASEAN region, to control the next epidemic in the complete landmark connected area, and to identify the major influence factor that can increase the COVID-19 mortality rate. So here we can understand that if you smoke, if you smoke, and if you have an underlying diabetic disease, chances are that your life may at risk. I think there is no one who smoke in our classroom. Okay, future recommendation. I only focus on the verified COVID-19 cases and death, but lack data about the number of tested cases per day. Chances are if you test more, and then the number of finding out the cases will be more. If the number of tested cases per day data will be available, and the ratio of the confirmed cases and the tested cases can also be considered as further. The study is performed at the country level, which leads to the few sample data. I recommend to do at the state and the district level. Further study can be proposed at the state and district level. Okay, thank you so much. And then I'm really sorry that I'm taking too much time.
Thank you, Coco, for your good work. And I think I have also taught about Lisa, and
Yes,
you have presented a case study on Lisa, and
yes,
very
sir.
nicely explained. Unfortunately, we have less time,
Yes,
but I will encourage a student to talk to you outside the classroom, because and we will not examine you, because you are not a credit student in this class.
yes,
You are just attending. So I
yes,
appreciate your interest. Thank you very much, Coco. So you can unshare. Thank you very much.
Yes, sir. Thank
Thank
you.
you,
Thank you
Coco.
very much.
Yeah. Now I invite Ms. Nograt and Sichu to make presentation.
Good afternoon, Professor. Professor, can you hear me?
Yeah, now you are co-host.
Let's share screen. I think
Yeah, it is coming.
Okay. Present. Okay. Okay. Right. Okay.
Situ, you can make it like presentation mode. Yeah.
I think it is in presentation. Yes.
Yeah, yeah,
It's in
it
presentation.
is.
Good
Okay.
afternoon, Professor and Teacher Propas and everyone. Today we are going to present about machine learning. Okay, next. This is our presentation outline. First, we introduce about machine learning, types of machine learning methods. Then we describe about supervised learning, a machine learning method. And within supervised machine learning, we explain about decision tree, naive-bayes, support vector machine, and then we conclude.
Hello?
Your voice is not coming.
Voice is not coming. Okay.
Yeah. Now it is coming sometime, but
Okay. We have to be close to, right? Machine learning is the term that we hear often these days. So what is machine learning? Machine learning refers to set of data-driven algorithms and techniques that automate prediction, classification, and clustering. It is a process by which machine learns to detect meaningful pattern in data. It is a powerful tool which combines the use of statistics, information theory, and computing. So making it a powerful and solid science, and firm mathematical base. Machine learning is applied in various fields, and the major application of machine learning is in classification. It is also widely used in remote sensing and GIS, and the recent version of ArcGIS software also supports some of the machine learning algorithm and tools. Some of the examples we can see for classification, we have maximum supervised classification, we have maximum likelihood, and in recent version of ArcGIS Pro, we have regression trees classification method as well. And for clustering, we have multivariate clustering, density-based clustering tools in ArcGIS. And for in prediction, there are various interpolation techniques in ArcGIS. Types of machine learning. Here we can see that there are different types of machine learning methods and algorithms. Supervised machine learning, supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, multitask learning, assemblage learning, neural network, instant-based learning. These all methods fall under a broad topic, machine learning. So since it is a broad topic, in this presentation, we are focusing on the supervised machine learning technique, and within supervised machine learning technique, we are focusing on decision tree, the popular supervised machine learning methods such as decision tree, naive-bayes, and support vector machine. So supervised machines, the algorithm that require external assistance for identifying of patterns or for any kind of prediction. These external assistants include knowledge obtained from past and present data. Supervised machine learning process requires two types of data sets. One is training data set and another is testing data set. Using the training data set, model is developed, and using the testing data set, the model is evaluated and the optimum model is determined. In this graph, we can see a general workflow of machine learning, supervised machine learning. When there is a problem, we need to identify the required data for the problem, and then we need to pre-process the data, and the data should be divided into two types: training data set and testing data set. The training data set along with algorithm or classifier that we use is used to develop the model, and the testing data set using various validation approaches is used to evaluate the data. And if the model performs well based on various evaluation criteria, then the model is used for classification, prediction, clustering, etc. And if it does not provide optimum result, then it is again trained and again evaluated. So this process involves a continuous process. Okay. Now I'm going to describe about decision tree. So what is decision tree? Decision tree are the type of tree that is classified by sorting data based on their values. How does a decision tree work? The decision tree asks questions and classifies data based on the answer. We can build decision tree from yes, no questions. We can also build decision tree from numeric data, rank data, etc. The classification can be also categorical, and it can also be numeric. So here, this is a very simple illustration of decision tree. Decision tree. These are the components of a decision tree. The root node is the top of the decision tree, and the internal nodes are the nodes. These three are the internal nodes, where internal nodes are the nodes that have arrows coming towards them and arrows going away from them, and leaf nodes are those that have arrows coming towards them, but they don't have arrows going away from them. So in this simple decision tree, here we have from the data ranging from 0 to 1. If the data is less than 0.5, then it is classified in the left hand side, and if the data is not less than 0.5, then it is classified on the right hand side. Here it is then further classified as if the data is less than 0.3, then it is classified as R1. If not, then it is classified as R2. In this manner, the data is classified into 5 classes: R1, R2, R3, R4, and R5. In decision tree, while using decision tree, one of the most important thing we need to focus is that how we are going to split these values, and how we are going to stop these values. The splitting rules and pruning thresholds have a major role in decision tree making. For example, for splitting of the decision tree, different formulas are used, like Gini index, Turing criteria, entropy, and for pruning, different types of thresholds are used. Thresholds are used. Advantages of decision tree. The major advantage of decision tree is that it does not require parametric data. It works on non-parametric data, so the data does not need to be in normal distribution. It can also handle feature interaction. It can deal with data that are not linearly separable. It can provide high performance for relatively small computational effort. Now, for disadvantages, it is very difficult to deal with high dimensional data. It can easily overfit, and sometimes can take a considerable amount of time to build a decision tree. It also cannot work with complex interactive processes, and there can also be propagation error while using decision tree. So when we are making when we are using a decision tree, at times it is difficult. Sometimes it is difficult because the one side may not be growing, and one side may keep on growing. So it is very difficult to make statistical significant decisions. So to address this and to address such type of issue, random forest was developed from the decision tree. So random forest is basically based on decision tree. So random forest is an assemblage method which uses several decision tree and obtains results from the averaging or voting of the results of those decision tree. So from a set of data, we select randomly from a set of training data set. Random data are selected and build one decision tree, and another random data set are selected and create another decision tree. Similarly, a number of trees are developed, and based on the result of those decision tree and based on the results of those decision tree, voting is done, averaging is done, and then the final value is decided. So what are the softwares for decision tree analysis? For decision tree analysis, there are various types of softwares like SIM Mintab, Weka also, as Ms. Pallavi showed in the morning, XLAT, R packages can also be used for decision tree analysis, including SPSS also, and MATLAB can also be used for decision tree analysis. So within the decision tree, there are a different type of algorithms like CART, C4.5, C5.0, Triad, etc. This is an example. This is a case study example of the use of decision tree. Here in this study, RS and GIS data, RS and GIS was used. Was to use to prepare thematic layers like lithology, lineament density, topology, slope, river density, etc. Those were the parameters for determining groundwater potential, and those parameters, with the use of multi-criteria decision method, was integrated with decision tree algorithms like C5 and CART, and then used to determine the potential areas of groundwater. So this study was conducted in Ritu County, Ali City of China. So here this is the algorithm to C5 algorithm to calculate the gain. And the gain is used for the splitting of the decision tree. In this model, two methods was used. C5 and CART decision tree was used, and it was validated using 10-fold cross-validation and kappa statistics. And for this case study, it was shown that C5 algorithm showed higher accuracy than CART. So optimum model was developed from C5 algorithm. C5 showed 90% accuracy, while CART showed 85% accuracy while classification. So these are the rules generated based on the C5 algorithm. So in this figure, we can see that when the lithology value is 4196, topology is less than 4301, and lineament density is less than or equal to 0.558, then it is considered as a very good area for groundwater potential. And similarly, such type of rules were developed based on the model for very good, good, and moderate and poor groundwater potential area as well. And here we can see how the model works. Like if the topology is less than 4316.5 and lineament density is less than 0.08, then it is classified as good. And similarly, the values that are have greater liner are considered as very good, have higher lineament density are considered as very good. So in this way, C5 algorithm was used. Now I would like to request Nongrat to continue with the presentation. Thank you very much.
Thank you, Siju.
Wait a second.
Hello, can you hear me? Hello.
Yes,
Yeah,
yes,
I
we
can
can
hear
hear
you.
you.
Okay, thank you. Okay, next I will talking about NFB. That is the one of machine learning technique that is used for clustering and classification purpose. It depends on the conditional probability that create a tree. This T is known as Bayesian network. So how does it work? This is an example that I show you to explain. So I transform this figure to the left one to be easier to understand. So I divide it to 3 classes for this light, neutral and light, and all of the last in the black box is a probability of each factors. So now how can we use a neighbor? For example, if analysis would like to find a cookbook male and adult person, what class will be? I will calculate the each of class to find the most value to be the class then. So this slide, I will calculate the probability by A multiplied by 1 minus C multiplied by F and multiplied by 1 minus I. So A is the probability of the light, and 1 minus C is the probability of adult, and F is probability of male, and 1 minus I is probability of cookbook. And then we will do the same as the neutral and light and find the result, the most value, most of probability, and we will answer that the cookbook male adult person will be classed as that class. Okay. And and now for this the neighbor works. Advantage of neighbor are ability to interpret problem in terms of structural relationship among predictors and take less computational time for training and no free parameter to be set. And also this advantages is performance decrease as data grows and cannot deal with high dimensional data. And next is software for the neighbor. The first one is R package, and next is Python program, and ERDAS, and Excel set for neighbor. And application of neighbor is most of the paper that we are looking for is about the hazard. something like assessing spatial livelihood for flooding hazard by using neighbors and DIS, and exploring land use and land cover for geotech, social sensing image using neighbor classifier, and also diagnosis of heart disease for diabetic patients use neighbor method. Something like that. And one is support vector machine. What is support vector machine? That is another most widely used set of the art machine learning technique. It is mainly used for classification. And how does it work? I will draw it for you to understand easier. Oh, oh, first I forgot this. SVM or support vector machine works on principle of margin calculation is down margin and hyperplane between classes by using support vector. So I will draw it for you to easy to understand. So the line is circles, red and green is sample, and it is different color because it is different class A and class B. And why we can separate class? Because we can draw the hyperplane by use the sample that's nearest of red one and green one nearest, and calculate the average to draw the hyperplane. This is one dimension to easy to understand. So now we can separate the class and we can find the hyperplane and margin. Margin is the distance of the nearest sample with and hyperplane that is called margin. So the two margin is the same value. So this is the two dimension. For now is the class 1 and class 2, and this is the hyperplane. Hyperplane is calculated from the nearest vector. It's called support vector, this one and this one. So we can calculate the hyperplane. And how do we know that the best hyperplane is? We will find the largest margin to calculate that. Yes. So the right one is the best vector support machine. So at the same time, in 3 diameter, it's transformed from line hyperplane to B-plane, but it's separate the sample to classes the same at the same principle. And now I will talk about advantages. Advantages of SVM is high accuracy and avoid overfitting, flexible selection, and accuracy and performance are independent of number of features, and good generation ability. And however, is disadvantages is too complex, and training speed is less, and performance is depend on the choice of parameters. So the software of SVM is a package the same and Python, and the right figure is a example of a paper of support vector machine. Okay, and for application of support machine with DIS is to comparison support vector machine and random forest algorithm for invasive and expensive spatial classification using airborne hyperspectral data, and vehicular carbon monoxide emission prediction using support vector machine, or using support vector regression model and GIS. And for example, a landslide accessibility mapping using support vector machine and GIS at the Golestan province, Iraq. Yes, and something like that. Also, in conclusion, the supervised learning technique, decision tree, neighbor, and support vector are effective in analysis and prediction in many fields, including GIS and remote sensing. These techniques are algorithms are dependent on training data set for optimum model developed. The testing and validation of developed model are required. Some techniques and algorithms may be more suitable for a certain application than others than we can see in above case 1, where C5.0 algorithm is more suitable for groundwater potential mapping than CART algorithm. Thank you very much. If you have any question, then please ask.
Okay, thank you so much, Nograt. So, Kun Prapas would like to ask some question.
Okay. My question is how to validate the model. You explain like 3 models, 3 techniques. So how to validate your output?
Professor, okay. Okay.
Prapas, you want to ask Sichu or Nograt?
Nongrat.
Okay, Nograt.
Because in the last slide you talk about the validation. So
Maybe next, Sichu can tell.
We are,
Time is very less, so who will reply?
okay, Professor. No, Professor, I will reply.
Okay.
Professor, model validation can be done via various methods, like the methods shown in the morning, like by Ms. Pallavi, like tenfold cross validation method, ROC method, kappa statistics. These methods are usually used for evaluating models using the ground truth data.
So it is the split method you are going to do 50-50 or tenfold. I don't see the tenfold here.
Tenfold. Sir, for
Yeah.
50-50, tenfold. Sir, for in the research we've shown there it was done in various different research, different methods were used. But for the research we have the case one presented, there was done tenfold and kappa statistics were used by them for validating the model.
Okay. Okay.
Sir, I have one question. Can I ask?
Yeah.
This machine learning, deep learning, and artificial intelligence means how are they linked to each other?
You are asking who?
Maybe Sichu or Sichu only.
Okay. Sichu has already replied, so Nograt can reply.
The ML and deep learning. The deep learning is a subset of ML, and ML is a subset of AI.
Okay, thank you.
Pass, any other question?
I'm thinking. In the decision tree, you think this is possible to do on the Microsoft Excel?
Decision tree, Professor, decision tree, the software XLAT, AXLSAT is an improvised version of Excel. So which supports decision tree, but I am not sure if the regular Excel can support decision tree. The XLSAT software is the improvised version of Excel, which supports decision tree algorithms, but I am not sure about the regular version of Excel if it supports decision tree.
Okay.
Anybody else? Anybody wants to ask anything about machine learning from Nongrat and Sichu? Okay. Sichu, can you tell me what is about a support vector machine is better or random forest?
Professor,
Which machine learning technique is better?
Professor, I cannot say like this machine learning technique is best. I think it is based on for which application which should be used. So for some researches, random forest may be best. So within random forest may be best, but for some support vector machine may be best. Like we can take example, random forest may be used to determine maybe used to random forest can be used for classification of for non-parametric data, whereas support vector machine is best for is also good for parametric data, and support vector machine is easier to use when we have like 2 to 3 dimensional data, but when the very difficult for support vector machines. Thanks.
Okay, last question to Nongrat. Slide number 9. Nongrat, can you go to slide number 9?
Yes. Yes.
Yeah. So while making the decision tree, who takes this decision? Like it should be less than 0.506 or greater than 5.506, or T is less than 4316.5 or greater than 4316.5. How to take this kind of decision?
Pardon?
Yeah, how
Can
to
you
take
ask again?
these numbers?
Each number?
These numbers, how people choose these number? 4316.5.
I think it's from rule that from the table from the right. Yes, the number of is come from literature review and no. Oh, it's a law that create the number from the model that they create.
Okay. Hello, Shishu. Can you unshare your document? And I invite now Rangsan and Bunthon to start their presentation.
Thank you, Professor.
Thank you. Okay. Good morning, Professor and everyone. My name is Langsan Kamkon and Mr. Bunthong Seng. The topic of our presentation is, can you unmute?
Yeah.
The topic of our
Can you start your
presentation.
video, Rangsan?
Can you unmute?
Sorry.
Bunthon and Rangsan, please start your video.
Oh, can you see our screen?
Your video is not coming, your screen is not coming.
You need to share your screen and the video,
Yeah,
Okay, can you see?
but not your video. I see your screen.
please share your video.
Share the video. Oh, okay. Sorry. Okay. The topic of our presentation is optimization of bus stop location using GIS technique and artificial intelligence. Okay, next. Okay, the first, let me talk about the introduction of AI. The artificial intelligence or AI is wide range blend of computer science concerned with building smart machine capable of platform tasks that typically require human intelligence also. In addition, AI is an environment in machine learning and deep learning is creating a paradigm shift in virtually every sector of tech industry. Another thing, AI works by combining large amount of data with fast interactive processing and intelligent algorithm, allowing the software to learn automatically from pattern or feature in the data. Nowadays, they have significant impact on our everyday life, such as email filter. We can filter the email from several people and the important email and send email. And another thing, Google predictive search, they predict the word that you try in the Google that they know that you want to search. And the last one, map direction. We can manage the path that you want to go. Okay. In this slide, I would like to talk about the application of AI in GIS. There are many applications of AI in GIS, such as the traffic management, mapping, AI attribute collecting, and data management, sensor controller in the car, and the last one, agricultural sector. The GIS use AI capability to enhance the function and user experience of AI software, including AI attribute collecting, AI survey and mapping, AI cartography, and AI installation. Okay. Next. In this case, there are two AI algorithms to optimize the base bus stop location. The first one, particle swarm optimization or PSO, is population-based stochastic optimization technique developed by Dr. Inberhead and Dr. Kennedy in 1995. So the PSO requires two values to compute which are the population. The population is mean the swarm. You can see the green area, and the candidate is the solution. Is mean the particle. The particle is the back point. The particle move around in search space grid by their own base no position, and with entry the swarm base no position. Okay. Next. Another algorithm AI is genetic algorithm A or GA. GA is the optimization technique to solve a complex problem by adopting natural selection and resolution. So the compilation of genetic algorithm is an iterative process that simulates the process of genetic selection and natural elimination in biologic evolution. Okay, next. Okay, this is the methodology and is the flowchart in this case study. The first one, they collect the location of bus stop and then transfer into the geodatabase data format and select all the parameters of bus stop relocation. The first technique, they use the loss analysis by using GIS to generate the best route to provide significant reduction travel time for street, and then they will get the best route map. And two AI algorithm is the PSO and GA applied to geodatabase in order to produce to optimize bus stop location map, and then they combine to optimize bus stop location map, and then they will get the validation of the resultant map. Okay, next. Okay, this is the case study area. They focus on 9 main roads in Amman city in the Jordan that have full functioning bus route and bus stop. In the map, we can see the yellow point is mean the existing bus stop and 9 main road. And in the road number 8 is the minimum length with the around 1 kilometer, and the maximum length is the road number 2 with almost 50 kilometer. Next. Okay. For data collection and preparation, the bus stop slope and the slope of the street was produced into a slope map by using GIS, and there are 3 main data. The first one is availability data to collect data and generate the population and land use map, and service area map to define bus stop within a radius of 400 meters. And the last one, the attribute data of bus stop compiled with existing shelter area and bay area, which is collected by field survey. Okay, next. Okay. For analysis of existing bus stop, the existing bus stop were analyzed according to combined with the standard specific for bus stop, there are 5 criteria. The first one is base area. If the value is yes, the scale will be 1. If the value is no, the scale will be 0. The shutter area is the same with the base area. I will go to the slope. If the slope value less than 2%, it means the excellent suitable of the base bus stop location. The scale will be 5 until the slope value more than 12%. It means the completely unsuitable. The scale will be 1. And the last criteria is population. If the value less than 1,465, the scale will be 1. And if more than, the scale will be 0. The condition existing of boarding bay, existing of shelter, slope of the bus stop, and population service. Each criteria was given the weight of 25%, and each criteria was given the scale as present. Next slide. Okay, this slide, they classify the criteria into 5. They classify the bus stop value into 5 categories according to their level of compliance with AASHTO standard. The AASHTO standard is mean the American Association of State Highway and Transformation Officials. We will see 5 classes. The first class completely unsuitable until the excellent. The medium, can you move closer to the medium? The medium is the high percentage with 67.12%. Follow the excellent with the 40.86%, and good 11.42%. And we can see two unsuitable is lower percentage with the 3.31%. The 2 unsuitable maybe is the some area are high slope value. Yeah, this is the reason that they are unsuitable. Okay. The next slide, Mr. Bunton will next continue the presentation. Okay.
Let me continue the presentation with the methodology. So first, I would like to start with the time travel calculation for each route and also particular route. So here, excuse me, do you hear me, sir? Okay.
Yes, I can hear you.
Yeah, so the time travel for a particular road, it means one single road can be identified by the function of distance, velocity, and the number of bus stops on that specific road. However, in order to build a model, additional assumptions need to be made. The first one is the distance between the initial stop to the next stop, which is defined into the distance between 400 to 600 meters, and the stoppage times at each stop is set to 2 minutes, and the average velocity of the bus from one stop to another stop is 40 kilometers per hour. But in some cases, the travel time from one stop to another require less than 2 minutes because those 2 bus stops are located close to each other. So in this case, the time travel of that road is calculated using this equation. So 2 here is the number. 2 here is the number of the 2 here is the number of the minutes, and n is the number of bus stop. However, in order to find the length, the time travel for the full length of the routes, it means the one length of the bus route can be computed using this function, this equation, where ni is the initial stop and nf is the final stop. As Rangsan has mentioned earlier, this case study was computed with 3 techniques. The first one is GS analysis. The second one is the PSO. So now I would like to first start with the PSO. And so one sub-algorithm of PSO was used in this case study, which is a vehicle routing problem algorithm. So what is a vehicle routing problem algorithm? It is the process of determining the optimal routes of delivery from one or several depots to users. So and it is very important in determining or minimizing the travel cost, travel distance, and also the travel time of those points. Here's in the picture, it explained briefly about the concept of the VRP. The scatter point here is the number of is the location of the customer, and the central building here is the depots. So the rule is that the delivery need to visit all these points once, at least one, and come back to the depots. So imagine without applying any algorithm, we cannot identify which one should be start and which one should be go next, and which one should be the final of that route. So by applying this algorithm, we can easily define like which route we can start and what should be go next, and at the same time we can return back to the depots. And in this study, the VRP's algorithm was processed using MATLAB software. After running this program, it provide the best distance between stop is around 416 meter, and this result was achieved after 1,200 alternation. It means the optimization was processed, running, and then it give the result, and it reprocess again, and it give the result. So this is the best route optimization. Okay. Here's the summary result of the optimization model using PSO for this case study. As mentioned earlier, the study focused on only 9 busy roads in a city, and here's the information about those streets. This is the name, the street length, number of existing stop, the current travel time, which is calculated based on the previous equation I have shown. And after the model, it proposed the new number of bus stop with the new travel time and the rate of percentage of change. The first street here, Zarhan, it has the length about 8 kilometers and existing stop of around 27 stop, and it takes around 60 minutes to finish one in that route. By applying the model, it suggests that this road should have only 14 stops, and the travel time was reduced to only about 38 minutes, and it has a rate of change about 40%. Interestingly, we can observe the street number 7 here, which has the highest length, the longest length among all the 9 streets, but it only has 9 bus stop exist. This means it has the lack of service. So by and it has travel time about 35 minutes, After the model, it suggests to have more bus stop with the 26 number, and the travel time also increased. As a result, the rate of change is about 93% slower than before. We can observe here the 9 roads are grouped into 3 categories. So the first category is category 1 to 4. It is noted that it has the significant reduction in time travel, as we can see the percentage here. And the second group is the road 4, 5, and 6. We can see there's a reduction in number of bus stops, but it is very minor. So there reduce only 1 bus stop for each of this. And the third group is from street 7 to street 9. It has to increase the number of bus stops, which result in the slower speed, the longer time for the travel. Another algorithm was applied is genetic algorithms. So mainly genetic algorithm was applied in reproduction, genetic reproduction, and to find out the likelihood of the offspring or the next generation. And here it was used to identify the number of bus stops as well. So GAs use binary integer programming to find the shortest closer path, closer tour. It means path from the sets of bus stops. The path it contains the subtour. So subtour is defined as the distance between 2 bus stops, and it is minimized by adding the constraint and rerunning the optimization. So here again, this kind of algorithm, it take like first it take 2 2 bus stop and process the algorithm, so it provide 1 result. After that, it has to add some parameter or constraint in order to generate additional result, which is considered to be better. And here we have in the study they have proposed this constraint. So the first one is the crossover of 0.8%, then the mutation of 0.85, and the population size of 121. And if you wonder what is the crossover, crossover is the combination of the 2 bus stops to generate 1 new solution, where the mutation is the random selection of those bus stops, of all the bus stops, to generate 1 solution. And population is the possible solution in a given problem. And the diagram here illustrate the process of how the algorithm works. So first, we have to give the crossover value, and then we have make it's give the mutation, and it moves to the population and evaluation. And the evaluation here, we can say a fitness value, which evaluate the whole model, like how fit is that solution to the group, to the whole bunch of bus stop. And finally, it select the best solution here. And here's the result from the GA model applied to those roads. Similarly, we can see the street are divided into 3 categories as well. And one is the road that has a reduction in number of bus stop. Another one is the road that has a increased number of bus stop. And there's one road here which is in different group, which is it has not changed anything, it still remain the same. And here we can see if you notice from before, the current travel time here, it is different from the PSO model, because the travel time here is generated based on the GA itself. And here it also proposed the number of subtour, which mean the distance from one stop to another. And another technique is they use the GS analysis to relocate those bus stops. So GS application was applied to relocate those bus stops to get the possible equal distance. So it means they try to equalize those bus stops between the equal segments. So let's say 400 meters. So all bus stops need to be in that range. So three criteria they was considered. First, those bus stops should not be located on the intersection. If there's an intersection road between two roads, so the stop cannot be located. Another criteria is the stop need to be within 400 meters, and another criteria is the slope. The stop must not be located on the slope that exceed the slope of 6%. In case the analysis model it gives it's locate the bus stop on the slope more than 60% within that 400 meter. So the analysis it will proceed further to find the possible nearest location which has the slope less than 6%. Yeah, and here's the result of the analysis in GS techniques. Yeah, similar thing. We have three groups of road which has a increased number of bus stop and decrease and have no change here. We can see the comparison of these three models. So overall, the travel times optimized using network GS analysis. It provides the highest time travel followed by the PSO, and we can observe that GS always give the shortest time travel. And here the GS give higher time travel because it consider the previous criteria like slope, distance, and also the intersection. Here I come to the result and discussion. The model developed give a significant reduction in time travel for street with the redundant bus stop. This is because the demand of the service in that area is below the capacity, which means that the waste of resource and energy when the bus travel throughout the route without any users. And additional bus stops were added also by the model for the street which has inefficiency bus stop. So this means that it will lead to the increase of the travel times. And in some cases, we consider that the people have to walk around 2,000 meters to reach the service. So the increase in travel time on the bus, it is the trade-off for the walking distance of the people. And here we come to the conclusion. GS model can provide a significant reduction of travel for the street with the redundant bus stops located at irregular interval, where GA model provide the minimum times travel with the regular interval, and PSO is the model that is in between. It provides time travel with GS. And it is significant that this model should be used by the decision maker in order to enhance the existing public transportation network and designs of the expansion of the networks. That's all from me. Thank you, Professor.
Thank you very much. Both of you have found a very good topic, and I think GA and PSO are very useful technique in optimization, and now in artificial intelligence they are being used. So I open the forum for question from the Khun Prapas. If any question is there.
Yes, I wonder the distance that you use in the calculation, you measure from like point A to point A at straight line or along the road. I mean the road in the real life, in the real world, the distance.
In the study, they mentioned that this is the real distance.
Mm.
Like, I mean, the road distance is not a straight line.
Mhm. And you show me some image. I don't remember which slide, but I see that you have like a distribution center. It's like every bus they start from the same origin and go in a different way, right?
This one.
This one, yes.
No, I mean, here's the example of, let's say, one route of the bus. So normally the bus always has its station. So let's say we go one round from AIT, and it's go to, like, let's say, Future Park, and then it will come back to AIT again. So we here it consider like AIT is the depot where the bus leave, and then it need to go and collect all to visit all the bus stop around the road in Pathum Thani, and then it will come back.
You mean only one bus?
Yes, yes. This is only
Okay.
this example refer to only one bus line.
Okay, I see.
Okay. Ransan, can you
Yes,
unmute
sir.
yourself?
Yes, sir.
Yeah. So, what is your opinion about particle swarm algorithm and genetic algorithm, which is easy to implement?
For in, you mean the PSO and the GA, right? Okay.
Which one is easy to implement?
The concept of the concept of PSO, in my opinion, is. Can you go to the slide?
Yeah. Yes.
Yes. Okay. In my opinion, is the particle is the black point, right? And
yeah,
the swarm is the magenta area and the green area, and the particle they come to they move from the magenta area. It mean the personal location, personal position, and then they come to the green area. Is the global bed or the base bus stop location. In this case, the green area is the most distribution of the population area. Yeah, they will know if the particle come here, the most of particle come to from this here. This is the most the base of the bus stop. Yeah, they can find like this. Do you understand me?
Not quite easy, but one thing is, in this thing, what are the parameters to be set in particle swarm or optimization?
Pardon?
For this bus stop problem, what are the parameters? Location is one. Another is.
In this case, we found the slope. The slope value is the problem for bus stop. Yeah.
What is the slope? What do you mean by slope?
The slope from the bus stop location. Yeah. If the high slope is mean the unsuitable bus stop location. Yeah. This is the one of the problem.
Okay. Any student? Any student want to ask any question? You can ask without any problem. Okay.
I have another question.
Yeah, yeah.
Why
Yes,
don't you
Professor.
take why don't you take the like population density or the
Yes,
community
yes.
area in the analysis?
Yeah, yeah, yeah.
You mean okay? I'm
Yeah,
sorry.
because the bus stop has to be located near like a community area, right? Because I
Yes,
see
yes.
your yeah.
Actually, this study they focus on also the population density. So the criteria is one is slope population criteria because in some area there are a lot of demand for the public transportation, but there's a lack of the service, so that's why this is used to optimize. I think here we can we use this criteria. So the first one is the Bay Area. It is defined like is that bus stop has the place for bus to park for parking, and shelter area is for the people waiting, and considering on the slope and the population density as well.
I think that it has to be like a cluster of the population, not population density, right? Because in some area, like you need a bus stop in Thammasat University because there are so many people. But in some area, for example, in the same province as Pathum Thani, the population density is the same for the whole province. But in some particular area, the number of population is higher than some other part. So it has to be taken in the analysis.
Yes.
Okay, thank you. Thank you very much.
And
Thank you.
I have another question for Rangsan. Can we take time of the day also, like traffic information in particle swarm algorithm? Like traffic information, like 6 to 8 o'clock, very high density traffic. All these things can be taken or not?
Sorry, sir.
Traffic volume. Traffic
Traffic
volume
volume.
in different time interval. Yeah. Because in transportation engineering, I'm a civil engineer. In transportation, traffic engineering, we used to do this traffic survey, then decide the bus stop, where to put the
Oh,
bus stop, and other things. So can we do it? Like
yes. I think
because
yes.
yeah, I think we have not taken those things. Population is good parameter, but I think traffic volume at different locations, like Khun Prapas told na, that whole province has some population density, but some areas are having too many people living in condo and come and take the bus and go. So this is one thing, and but I think this is a very powerful technique, and it can be used. This is a message for all students, like PSO and genetic algorithm. Not only in finding the bus stop, many other applications you can use it wherever optimization is to be done. I will be very happy Bunthon can tell me one application. During COVID time,
Sorry, sir. Can you
this is the one application you have taken, optimize means doing optimization for bus stop location. But suppose during COVID time, the way of life is changing. So some application we can do using like a genetic algorithm or particle swarm algorithm. What about
maybe can
deliveries? Like people are ordering the food, ordering the material, and
yes, I think it can be applied in those areas.
yeah. and even vaccination points where the vaccination can be done. I think many things can be done, and rapid decision making can be done for zonation, and then how to efficiently do the things so that people movement is minimized, and all the services can be provided. I think many applications are possible as far as I'm thinking, and all student can study this term paper very nicely, and hopefully some of you will use it in your thesis. So I will stop Bunthon and Rangsan. Very good presentation. Now I go for the next one. Shiva
Thank you,
Babu.
sir.
Yeah,
Thank you.
thank you. Now, Shiva Babu, you can share your screen.
Sir, can you see my, can you listen?
So, okay, Shiva.
Good morning, good afternoon, everyone. This is Shiva.
Yeah.
Today I'm going to present about the GIS and big data visualization. In this presentation, I'm going to cover in the introduction about the GIS and big data visualization and some background about the big data and big data as like is an alternative visualization tool for GIS or not, and some of the GIS limitations and conclusion. So when big data emerged in the early 2010, stronger and more fundamental changes are asked in GIS development, as it is characterized with large volume as a vast variety and a fast velocity. Big data has been released explosive datasets in social media and other complex platforms. And in this background work, we will discuss about what is big data and geographical information system. In big data, we we're gonna cover about the big data characteristics and components and big data processing and analytic techniques. So while coming to the big data characteristics and components, big data can be defined as data sets which have various data styles, like fast processing speed and hard to manage and analyze with existing data systems. These characteristics of big data are summarized with 3V, which denotes like volume, velocity, and density. First, big data deals with large volume datasets, usually more than terabyte size, that usually comes from GPS, social media, and other sensors. And while coming to the big data processing and analysis techniques, big data process with its elements in which the process as data source, collection, storage, and processing. With, with analysis and visualization, each step of process has considerably different elements from the first dataset database system that generally dealt with structured datasets. And big data visualized and demonstrated is a process that analyzed datasets are expressed with graphs or table formats. And big data visualization is compressed with traditional data visualization is that the form uses word, text, and tag clouds. And while coming to big data and GIS, big data, big data and GIS are able to share several aspects together because they are similar in elements and data processing. As you can see in the figure I just shown the GIS data processing with its elements. They are the popular open source or commercialized software that web-based online GIS system, which plays an important role in processing and analyzing GIS data. First, GIS uses data that contains location or space, therefore it displays in a map or picture form. Re- uh, or recently, area or satellite data become more and more important as new techniques are introduced. As locator-based data, GIS data is usually large size as it is big data. Second, GIS collect field data such as street information, closest circuit TVs like CCTV or other location-based database. If database do not have provide location information, GIS techniques should perform a geocoding process to convert into GIS datasets. People participate is also an important way to get GIS data. So the particular GIS system becomes a significant field of GIS. And while coming to big data as an alternative visualization tool of GIS, in GIS visualization as a limited as in visualization and demonstration technique, big data and GIS as their share the together in some aspects like however there is some aspects that cannot be shared or come together. In figure we can see there are defined area A as a GIS visualization exclusive area and C as in big data visualization exclusive area and B as in overlap area between two techniques. And you can see an example difference between GIS visualization and big data visualization. In this example, it's gender difference, genders and ethnicity in technical company which online tablet public. So while coming to the visualization overcome GIS limitations, GIS visualization has a limitation since it is basically rooted at a spatial content and geographical maps. GIS visualization first priority trends more to the geographic that to be information or graphical. Location materials at GIS visualization as it did at mapping and geography. Big data visualization open a new origin in GIS visualization because it does not strengthen the spatial content, but also it gives new meaning and insight to GIS map and demonstration. And conclusion, big data is defined as very large size and various format dataset and analytic methods based on engineering techniques and social network services, including static fusion and new visualization. A narrow definition of big data impairs data source, collection, storage, and other issues, but it wider define, embrace analysis and demonstration aspects. Thank you.
Shiva, the slide that you have submitted is different than what you have presented today. I think there are some extra slide today you have presented.
Yes, Professor, I just added the differences like differences
Yeah.
between GIS
So
visualization.
please send me the updated one.
Yes, Professor.
I will upload it in the term paper thing so that people can understand what you want to say. So
Okay.
I will like to go. This slide, can you explain? Because I could not understand it.
It's just a simple example that how can like GIS visualization and big data can represent the visualization techniques.
Yeah, explain it.
Um, it's just based on the data. It's showing that male has like it's for 60% of the male are. It's not too clear.
First of all, this is not a GIS it is not a location based visualization. Okay,
Uh,
this slide.
yes, Professor. It's
Just
just
like some kind of a graphical representation of some information.
Yeah.
It is not a map. It is not on the map, correct?
yes, Professor. It's just the representation of tech companies.
We show just only the number of something
Yeah. So
on the
what do you mean? What is the big data visualization means? Can you explain it?
It's just a technique where we can visualize the data more
More what?
accurately. More accurately.
What do you mean by accurately? GIS is not accurate. Shiva, what is the technique in this paper, in this presentation or paper?
Actually, we
You
don't.
have to highlight.
We just analyze on the big data analysis and JS.
Okay, Kun Prabhas, do you have any question?
Yes, can you go back to the first previous slide, the map?
Yes, bro.
Yeah. Okay, what is the map show? What do you want to tell by the map, by using the map?
It's
Cities
just
by elevation.
it's just the example thing how the arc view will show the visualization.
Yeah, what is the meaning of this map? Cities by elevation.
It's it's
Okay, for example, if you get some data, big data from some organization, how do you show those data into the map?
what do you mean, like the technique or else the platform what we use?
The way how to show the data, like you got the data in the Excel file,
Okay,
and yeah, and you want to present your data, the Excel file into the map.
so for the presentation we can use like Power BI or Tableau. In Tableau we can represent the data, Excel data directly to the map.
Okay.
Yeah, we have the features that we can directly select the map and we can represent the data.
Okay. What is Shiva? How to represent velocity into the GIS? Velocity of big data into the GIS.
Well,
What is big data? I think most simple question I'm asking you. What is big data?
where multiple data sets, like multiple values are stored.
That is multi-criteria, multi-factor. That is GIS. But what is big data?
Multiple data representation.
Okay. Okay. Kun Prabhas, you have any other question?
I have only the suggestion.
Yeah.
So in the slide, first you need to put the slide number, and you
Yes.
have too much text in the presentation, and you just read in what you put in your slide. So next time in the presentation, you need to show just only the keyword and the image. You don't need to put too much text on that.
Okay.
Yeah. That's a very good suggestion. And I will like to suggest all students that this is the common thing we are requesting all of you. Slides should be numbered. Plus, you have to have the small sentences, keywords, and when you are speaking, just take the keyword and explain it. You don't have to write everything on the PowerPoint. PowerPoint is just to take the attention of the audience and then explain them how the things are. But if you write complete paragraph, then audience will try to read it. And that same thing happens, Shiva was reading it. And now when I'm asking question, he is not replying that one. What is big data? So there are three components of big data that I teach. So I think all those things you have to understand, Shiva. And all the student today, some people you might have seen, they're very comfortable in explaining. And I think after master degree, you will be asked to make presentations in the real life. You cannot say, no, I cannot. And if you make a bad presentation, nobody will be paying attention to you. So life is very tough. Presentations are going to be part of your life now. And especially during the Zoom time, people will ask you to make presentations, and you should have the skill how to speak so that every word is clear. You are talking only most important thing. Don't go around the bush, because people make out that, yeah, real thing is not coming out. Now GIS visualization is very important. Topic is very important you have taken, like big data visualization in GIS. You cannot say GIS visualization is totally useless. The GIS is a ever evolving technique on which many things are coming. Today you have seen like AI, genetic algorithm, so many things, machine learning, everything is going to become like a small tool in the GIS. GIS is an information system. It is not a only one tool. It is a collection of tools. So you cannot say GIS is having this problem. You are strengthening, but what is big data? How we can show it? That technique I was not able to catch today. What you wanted to say. So that's it. So I will stop here for your presentation, and we will see. There is no communication from Raja. He is not well. That's what you told me.
Yes.
So if I get some communication, I will find out what we can do for him. Now, next presentation is by Yanisha, but I will give 5 minutes break to everybody. We will start it at around 3:40 and then go up to 4:10. So 10 minutes, all of you can go for water, biological break, and come back at 3:40. And Yanisha and Usaha will present. Thank you.
Thank you.
Hello, Yanisha and Usaha. Welcome back.
Yes.
Yeah, so I have made you co-host. So you can put your presentation,
Okay.
share your presentation and start presentation now.
Mhm. Okay, can you see now?
No.
Your presentation is not coming.
Mm,
Double click to enter full screen mode.
now can you see?
Now it is coming. Yeah.
Okay.
Okay.
So I'm not sure what I'm going here or not.
Who will start?
So
Okay, yeah.
may I start?
Okay, up to you.
So good evening, everyone. We will present our project term paper. Our topic is factor analysis. So our presentation consists of 7 parts, including what is factor analysis, type of factor analysis, exploratory factor analysis, confirmatory factor analysis, and combining exploratory and confirmatory factor analysis, and exceptions for factor analysis. And last one is example application. So to begin with, in generally, factor analysis has defined by many scholars, but the meanings of factor analysis is not too much different. Factor analysis is a useful statistical method that grouping or combining variables into one group, which the relationship is going to be both positive and negative. So variables within the same elements are highly related. On the other hand, variables with little or no relation to each other, they cannot be used for either developing neutrally, testing, or confirming an existing theory. For factors, it has two types. One is exploratory factor analysis, and second one is confirmatory factor analysis. Um, For exploratory factor analysis, the objective of this method has 2 points. Uh, First one is the number of common factors influencing a set of measures. And second one is the strength of the relationship between each factor to each observed measure. Then how can we use uh, exploratory factor analysis? Normally, we can use exploratory factor analysis when we do not have knowledge or of the variables. We do not have knowledge. We do not know about their structure and their relationships. So we use this method to study the structure of variables and reduce the number of existing variables together. So the performance for exploratory factor analysis is consists 6 steps. The first one is construction of correlation matrix. This step is to evaluate the relationship between variables, and the next step is determinations of the number of factors to be considered. This is
a number of factors equal to the number of eigenvalues of correlation matrix greater than 1. And the next step is extractions of integral set of factors. This is a maximum likelihood for this one. Extractions of integral sets of factors. The component of this is something like maximum likelihood, principal components analysis, and principal extraction, which be a common factor analysis. So after that, factor rotation. For factor rotation, this step has two types. One is orthogonal. The orthogonal produce uncorrelated factor, while the first one is orthogonal and the second one is orbital. For orthogonal produce uncorrelated factor, while orbital give correlated factors. So the next step is interpretations of our factor structure. For interpretation of our structure, in each measure is linearly related to each factor, which is called factor loading. It is similar to standards regressions coefficients. Try to reverse to the scale of factor loading by multiply or loading by -1 factor. So the last step is construct factor score for further analysis. Factor score is a linear combinations of all the variables weight by the corresponding factor loading. So we can normalize the value by assign 1 as strongly positive loading and -1 to strongly negative loading, and we can put 0 to intermediate loading. So what I will present here.
Okay. Confirmatory factor analysis. The objective of this topic is to determine the ability of a predefined factor model to fit an observed set of data. Commonly, it's used when the analysis has knowledge of the structure or of the structure of variable relationship. It can predict which variables are related and belong to the same element. However, any variable has no relation. Next, performing confirmatory factor analysis. We have first step, 5 steps too, but it's not the same. First step is define the factor model. In this step, include the number of factors and defining the nature of factor loading. Second step is collect the measurement. The measurement of your factor variable need to do the same experimental unit. Next step is construction of the correlation matrix. This step is to evaluate the relationship between the factor. Next step is fit the model to the data. A method is required for obtaining the estimate of factor loading. And next step is evaluation of model adequacy. It evaluate the amount of discrepancy between correlation metric by model and the actual observed metric after the model with the data. And the last step is comparison with other model. Almost the test of individual factor loading can be compared with other test factor model by examining RMS error. Next. Okay. Let's start about the combination between exploratory and confirmatory factor analysis. Normally, we want to use EFA. It means uh, exploratory factor analysis. If you can have if you don't have the strong theory about the construction underlying the response to your measure and CFA, if you do it, it's reasonable to use EFA and then have follow with CFA, but this must be done by using separate data set. You just fit the data. If you directly put the result of EFA directly to CFA on the same data, an acceptable procedure is to confirm EFA on one half of your data and then test the generality of extracted factor with CFA on the second half of the data. If you perform CFA and get significant lack of fit, it's perfectly acceptable to follow this up with EFA to try to locate inconsistency between the data and your model. Okay, next.
So there are the exceptions for factor analysis. Basically, it has 7 points. The first one is normal distribution of many variables through a simple multi-variables distributions data, and 3 is no abnormal value. 4 is no perfect collinearity. 5 is there is no homoscedasticity between variables. 6 is the variable has a linear relationship, and the last one is the data has an interval or ratio scale.
This is application of factor analysis in GIS. This application is used the assessment of groundwater quality in India. It uses factor analysis to evaluate the quality of groundwater. The result of this shown in this table. This table is the correlation chip metric. No correlation. Correlation metric of 11 chemical parameters of the groundwater quality assessment, and we have the table of 4 factors that is the output from SPSS software. Next. This is study area. Study area is Thiruvannamalai district of Tamil Nadu in India. We use groundwater in 30 well, 35 well. Okay. The objective of this paper is to assess the suitability of groundwater for irrigation based on index. It contains SAR index, RSC index, and PI index. SAR index, RSC SAR index, as you know, is about the SAR index, and RSC index is suitability based on irrigation index, and PI index is mean the permeability index. The method of the study. First step, they have water sample testing by the wet chemistry laboratory of Center of Water for Water Resource. And next, we use data analyzing by using correlation metrics. That is Pearson correlation metric. And after that, we use the index. suitability based on integration index. We will get the table in the right side. After that, you can use the result of the right side table to buy a PSS software, and you will get the uh, result of the right side table. That is the factor output. We have four factors, and the four factor output you can see in the factor 1. They show higher positive loading for potassium and sodium, and the second factor is show moderate loading. We have four factors that moderate loading. It contains sodium, potassium, bicarbonate, and carbonate. In this manner, this part it can consider to clarify the water type, and factor T is higher stacking for pH and carbonate, no carbonate and calcium, and factor 4 is higher stacking for magnesium only. Okay.
Okay. Already finished for our presentation.
Your presentation is finished. Usaha and Yanisha, what you presented now and what presentation file you send me is different. Can you send me the updated?
Yeah.
Yeah. Now let us go back to previous slides.
This.
First, you have to do the exploratory factor analysis to reduce the dimensions of factor, correct? You have something like 11, I think, parameters. And from
Yes.
11, you have found out, I think, 4 factors, correct?
Yes.
So how do you get that? Pathakon, you can explain?
I think we use confirmatory is used from the factor from literature review from another research thing. I find many research is use the factor at the same parameter. It 11 parameter too. I think they use like this.
Okay. And Yanisha?
Yeah.
What is the difference between exploratory factor analysis and confirmatory factor analysis?
For exploratory is that is the method to find like Italian variable in data, but confirmatory this is to confirm the curtain structure in the data that's collect or not. So in confirmatory, so we and hypothesis is and hypothesized model is due to the our theory and what you want and what we want to confirm it. So I found that like some people can use exploratory first and then just use confirmatory to do that if we want to do like if you want to see like the new data set map to the structure or not, something like that. So it's
Kun Prapas, any question?
First, I would like to give a comment.
Yeah.
First, there are too much text in the slide, and the image you put is not so clear, especially the table. I cannot see the numbers so clear. Okay, and My question is, Janisa, what is the homosyndactic city?
Don't.
What is homosyndactic city?
What did you mean?
Slide number 10. You just talk about it. Go to slide number 10. No. Forward. Yeah, this one, number 5. Yeah.
Homoscedastically.
You mean this word, right?
Yeah.
I found this one in the video, and this is something like the technical word or something. I'm not sure about this one, but in what in my mind is it be like the I'm not sure about this. Okay, I'm not sure about this word in English, but something like stabilities of variance or something like that.
Okay, so it's gonna be your homework. So next time, if you put some technical word, technical term, you need to know the meaning of that. Okay. Okay, and Patagon, go to slide number 11. Yeah, you have the design matrix. So where did you get the number from in the matrix? 0.116, 0.115. On the left image.
Left. The output
in
of
the correlation matrix.
the output of this is come from the index that it contains star index, RST index, and PI index. And in the first in the paper in the first one we show the in each index how many values, and this table it show correlation of each index. And you can see P1, P, P, P and P in the first one, and one in multiplied by it means one. You understand?
Actually, in the diagonal direction, it's always 1 because it's the same.
Yes.
Yeah.
But in the first, it's not it is only the value of table in each parameter, but this table is for parameter to show the correlation metric.
Okay. Any other student? Any question? Okay. I will ask one question to all the students. Anybody can reply. What is the importance of factor analysis in GIS? Anybody can reply. Unmute yourself and reply. Bilawan?
In my paper, there was something called CPA, component factor analysis. No, something like that. It is to reduce the variables.
Okay, very good. Very good. Okay. And I will ask another question. Why do we calculate collinearity matrix in factor analysis? Shashank, you don't reply. Yanisha and Pathakon don't reply. Any other person would like to reply? Siva?
Yes, Professor.
Why do we need? Why do we make collinearity matrix in factor analysis? Bunthon?
Professor, I think it is used to find the relationship between those vectors.
Yeah. Thank you. I think correct answer. So, Kun Prapas, any other question from Yanisha or Usha Pathakon?
No, sir. No, sir.
Okay. Okay, then some people have made additional slides into a PowerPoint presentation. So please send me the updated one that I will like to upload on the Moodle so that a student can read it. And as I told that there are going to be some question on these term paper. So all of you have to quickly read the PowerPoint and report so that in the exam you can answer those questions. So thank you very much. I will stop here. Thank you, Kun Prapas,
Thank you,
for
sir.
being with me. And thank you, everybody. I hope you have learned something today, new techniques. And if you are interested, you can go through the presentation whenever you are taking tea and coffee, because everything is on your Moodle, and try to learn new things. All the best.
Thank you, sir. Goodbye.
Thank you, sir.
Bye.
Thank
Bye.
you, sir. Goodbye.
Thank you. Goodbye. Goodbye.